Alright, in this video I'm going to be showing you an example of solving quadratic equations, but when a does not equal 1. So with our standard form ax squared plus bx plus c, we're talking about when this coefficient in front of the x squared term is something other than 1. For example, over here with this quadratic equation, a is equal to 4. When we're doing that, we need to make sure that we're a little careful when we're setting up our box method and thinking about our factors. At the beginning, we can set up our box method very similar to how we do when a is equal to 1. We're still going to put our 4w squared, the squared term, in the first box. We're going to put our constant in the last box, negative 5, and off to the side we're going to put our 19w. Now when we think of our factor pairs, we have to account for the fact that this is not 1. Usually we can look for numbers that are factor pairs of this constant, but that's because when you multiply the constant times 1, you'll get that number. In this case, negative 5 times 4 is negative 20. So we're actually looking for factor pairs, two numbers that will multiply together to give us negative 20, whose sum will give us positive 19. So let's list some factor pairs of negative 20. 1 times 20, 2 times 10, 4 times 5, and then one of these factors for each pair would have to be negative. If you take a look at 19, we could use 1 and 20. If we make the negative 1, then negative 1 times 20 would give us negative 20, and negative 1 plus 20 would give us positive 19. So I'm going to use that one. I'm going to say negative 1w and 20w. The order I write those down in these boxes doesn't matter. And then I need to factor out any common factors from each column and row to find these outside values. So let's look at 4w squared and negative 1w. The only factor that those have in common would be w. We can pull out a w. If I look at 4w squared and 20w, they have in common a factor of 4 and w. So I can pull out a 4w. If I look at 20w and negative 5, they have in common a positive 5. And last, negative 1w and negative 5, I can pull out just a negative 1. So I end up with, and I can check my work, 4w times w is 4w squared, 4w times 5 is 20w, negative 1 times w is negative 1w, and negative 1 times 5 is negative 5. Awesome. Okay, now I can write down my factored form of this quadratic, w plus 5 times 4w minus 1. Again, remember with multiplication it's commutative, so if you switch the order of these factors, it's still the same thing. Because of the zero product property, if I know I have two values that are multiplied together that give me 0, then I know that one of these or both have to be equal to 0. So what value of w would make this piece right here, make this equal to 0? Well, that would be w equal to negative 5. The second piece might be a little bit harder to see just by looking, but if I set 4w minus 1 equal to 0, then I can solve if I can't see what the value would be. So I'm going to move the 1 over, I'm going to add 1 to both sides. I got 4w equals 1, and then to solve for w I'm going to divide by 4. So w is equal to 1/4. So 1/4 would be the value that we could plug in here that would make this part of our factors equal to 0. So my second solution would be w equal to 1/4. And these would be my two solutions to this quadratic equation.